In all the past papers, it's in this method, like so the way how I explain.
Oh, okay, sir.
So somehow, so you may just rearrange the equation to get what? When you get the equation rearranged, so the Kmax thingy is what? HF minus pi. So this looks like
Gradient
what?
is okay.
Y equals to M, that's the gradient, and the variability is what we can change the independent one in the x-axis?
Frequency.
And this one is like C gradient, sorry, intercept. So the intercept is the what work function. Here this point is what the threshold frequency, that means the minimum frequency, and the gradient of the graph is always what? M of the graph, delta y over delta x. That is what? Planck's.
So the work function is negative.
No, negative means you have to provide energy to remove it.
Right.
Low
Right.
energy being wasted.
Okay.
So here it's provide some energy to the electron. That's why it's negative, and half m square. This any point is representing what? Kmax of related to the incoming photon. Any point. So changing different frequencies, you may get what? Different what? Wavelengths. Sorry, different kinetic energies. And plot the graph.
Yeah, got it.
Okay. By changing different radiations here. Now see, it changes what? Frequency. Frequency means the, what is it?
Frequency is the,
frequency is the shining light. Different shining lights like frequency of F1, F2, F3, F4, F5, likes of different frequencies we can generate, and using this cell we can just determine the amount of stopping potential for regular intervals. Okay.
Yeah.
So this one contains really simple questions.
So, but in the earlier part, so there are only specific energies that can occur, no, sir?
Yeah.
So then, in this graph, wait, so there are only specific frequencies, right? So there are no in-between frequencies?
No,
You can have
we use different frequencies and plot the Kmax value. Right?
Yeah.
Kmax value is detected using what? Step potential. So using, I told you, inverting the battery, using the inversion of the battery, you can find out what? Stop potential.
Yeah.
Right? In this one, they were referring to something else rather than changing the external potential. They were talking about something like letting the stuff to reach to the other side until it got some positive charge over here. It balances what? The maximum kinetic energy and the incoming the potential difference is generated across this charging is self-charging. So once this plate also becomes some positively, once the photon plate becomes positively charged, why? Since all the electrons being transferred to the other side.
Yeah.
So that's what it generates its own positivity and.
So at the point where the current keeps increasing, and then when the stoppage voltage is current goes back to zero, at that point only we take the stoppage voltage, right?
And using the stop voltage, I told you how to find out the Kmax value. So using this equation, we can easily find out the Kmax value. So graph is according to the frequency and according to what? Kmax.
Yeah, got it, got it.
Or do you need further more explanation for this one?
No, sir. No.
Okay, good. Photoelectric experiment is also explained here. Shall we discuss these questions? The checkpoint questions of the book before going for the tute questions.
Yeah, okay, sir.
So I'll give you like 7 to 8 minutes. Finish and let me know. Okay.
I was using minus 19, that's why.
Here. For the first one, this one you have to convert from what electron volts to convert it to electron volts, joules to electron volt conversion. What you just have to do is divide this by 1.6 into 10 to the power minus 19. So like pi equals to energy in joules 3.68 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19. Minus 19 and minus 19 cancel off. You may get something like 2 point something. No?
2.3. 2.3.
2.3 electron volt. In the next one, so the why would iron not release photoelectrons if the red light was on it? Because iron has a strong but higher work function, so the red light is not enough. So how would this result change? The red light were turned to double the brightness? Nothing, because useless. There are many. So it's like the number of photon count increase. This is the initial photon count. Now the photon count being doubled. Useless because none of the photon is capable of removing electrons. Understand?
Yeah.
Okay. How does the photoelectric cell experiment describes the above get over the problems that the electrons released will have a variety of kinetic energies depending on how deep the metal they start, because for the same frequency you may get different different work functions, so different value. Why? Because electrons at the top of the surface will release easily. Electrons which were like deeper in the metal take more work function, so that's why the frequent electrons have different kinetic energy. So
Yeah.
why it is the threshold frequency for calcium? So like cesium, it's like how? So pi equals to HF naught.
Wait, sir, can you explain the third question again?
Work function cell photoelectric cell experiment describes how to get over the problem that the electrons released will have a variety of kinetic energies depending on how deep the metal they start. How?
Use a very thin piece of metal.
Yeah, thin piece of metal, thin piece of coating. So it's now normally we can coat something on the cathode.
Yeah.
On the cathode, coating a very thin film, right? Thin film of what? Metal in interested, right? So only the stuff removing from what? Thin film of the metal.
Wait, sir. What's the film for, sir, again?
Film means the metals can be coated on.
Yeah.
So this coated metal,
Okay,
the film
okay. Got
is
it, got
like
it,
a
got
very
it.
thin film, can
Yeah.
easily, right? It's only releasing from the surface. Otherwise, if you use a thick metal, it may have different kinetic energies. What is the threshold frequency? So how to find out? So it's given like in, wait, how to go to there? What is the value for cesium? It's really annoying now. 2.1 electron volt, no? 2.1 means in electron volts. How to convert to joule? EV to joule, how? Multiplied by 1.6 into 10 to the power minus 19. So what can I do now to get it to joules? 2.1 into 1.6 into 10 to the power minus 19. What did you get as the answer for joule value? Chamika?
3.36 into 10 to the power minus 19 joules.
Minus 19 joule. Okay, now can apply it like equals to, wait, what does it ask? Threshold frequency, yeah. HF naught. F naught equals to E over H. So 3.36 into 10 to the power minus 19 divide by 6.3 10 to the power minus 34. What is your result you just found?
F naught equals 5.1 into 10 to the power 14.
5.1 into 10 to the power 14 hertz.
14.
Right?
Yeah.
This is how it is. So in the next week, we have to learn, what is it? Electron diffraction and interference, that like the de Broglie. So better to read this before joining to the class. And even today, Jason had a big problem, like how this behave, likes of what electron microscope and the stuff, because in this textbook you don't have anything like the structure of what electron microscope and other things. So you'd better watch some YouTube videos regarding the mechanism of electron microscope. I will explain you myself even. So then you will get some clear idea why are we using the electrons instead of what regular light, because the light has a long wavelength, and how to change the wavelength even. So, and the last part is the electron energy. It seems to be really scary, but if you read and come, I can explain this within like 20 minutes. So this lesson is not scary, it looks only scary because when you see many diagrams, you may think like, Amma, there are very hard questions and stuff. No, this is not hard. And even in my tute, I explain really easily and perfectly. So wait. What the heck? Okay. Kamika?
Yeah. Got it, sir.
Yeah.
So that's in the 2 tubes you gave, right?
Yeah. In those tubes, I gave. So actually in the first one, see, absorption spectra, and the procedure is also there because the gas discharge tube procedure is not in the textbook. That's why I include this one.
Yeah, okay, got it.
The gas discharge tube and the neon strip is not properly explained. So you may get the idea about this one. And after that, we can just discuss these questions like of the photoelectric cell and like the stuff. See, as many questions are from photoelectric cell and the metal. So just refer that tube and try these questions in that bigger tube.
Yeah, okay, sir. Okay.
If you can get through these ones, you will never get distracted in any exam, because these ones are like covering all the way basic questions that may come. So if you know how to handle these ones, so how can you get tricked in the exam? So never. So it's time
Yeah.
to wind up the class, I think, for today.
Yeah.
Thank you then.
Okay. Thank you, sir. God bless you, sir.
Okay, God bless you.